Welcome back to our flipped chemistry classroom. Today we're continuing with our conversations about some important concepts that underlie chemistry before we jump into the meat of chemistry. So today we're going to have a quick discussion of density. So density is one of the physical properties that we use to describe matter. And it's probably one that you've used before. It's useful for chemists in a lot of ways. One of them is that it allows us to identify materials because most materials have different densities. It's also something that we can use to convert from mass measurements to volume measurements or from volume measurements to mass measurements using as a conversion factor or as part of the dimensional analysis that we've been working with. So just a quick reminder of what density measures. So density measures mass divided by volume. And in the chemistry classroom, we're going to usually express density as either grams per cubic centimeter or grams per milliliter. And so mass over volume. So we could talk about mercury. Although it's a liquid, it's an incredibly dense material. 13.6 grams per cubic centimeter. When we look at platinum, it's even more dense at 21.5 grams per cubic centimeter. And so if you have the same size sample of mercury and platinum, the platinum is going to be heavier because although they have similar properties, the platinum does have a higher density. And then aluminum, you probably are familiar with, is one of the least dense metals. And so it has a density of 2.7 grams per cubic centimeter. I certainly don't expect you to remember these. I simply want to give you a couple of examples. Okay, so we're going to jump right in and do a little bit of problem solving and determining of density, and then we're going to use it as a conversion factor. So the first problem we're going to jump into tells us that we have a piece of copper that has a mass of 57.54 grams. It tells us that that same copper is 9.36 centimeters long, 7.23 centimeters wide, and 0.95 millimeters thick. And it asks us to calculate the density. So we know that we need to find the mass, well, we're given the mass, and we need to find the volume in cubic centimeters. And so we'll go back to our basic math and we'll remember that volume is length times width times height. But we're going to have to be really careful because we're given these dimensions. Two of them are in centimeters, but one of them's in millimeters. So let's switch over to our document camera here for just a minute so you guys can see as we work through this problem. Okay, so we are given this very first problem that asks us to calculate the density of the copper. So the first thing I'm going to do is write down the formula that density is equal to mass in grams over volume in centimeters cubed. And so I know I need to find the volume. Well, I know that volume equals length times width times height. And I have written down the length, the width, and the height, but I need to have them all in the same units. And since I know that I want centimeters cubed for my density, I'm going to go ahead and convert this millimeters to centimeters. Now, I happen to know that there are 10 millimeters in 1 centimeter, but if you weren't sure, you can always convert your millimeters to meters and your meters to centimeters. And so we know that our height is 0.095 centimeters. And so our volume is 9.36 times 7.23 times 0.095. And let me grab a calculator and work that out. 9.36 times 7.23 times 0.095. And that gives us 6.43. And now I'm going to put the mass, which was 57.54 grams, over the volume, which is 6.43 cubic centimeters. And we get a density of 8.9. So let's go back to our PowerPoint and let's take a quick look. Let's see if we manage to get the same answer this time. Okay, so 8.95, but because this only has two significant figures, we're going to round that to 9.0 grams per cubic centimeter. So pretty simple and straightforward. Let's take a look at some of the other descriptions of this particular property of density. So density is what we call an intensive property of matter. It does not depend on the amount of matter that is present. So whether I have a little bit of styrofoam or a lot of styrofoam, it's going to have the same density. But if I have the same volume of styrofoam and brick, the brick is going to have more mass. So extensive properties do depend on the amount of matter that is present. So those are things like mass and volume. But because we know that density is constant, as volume increases of a substance, so does its mass. Okay, let's use density one more time in a conversion problem. We're given that mercury has a density of 13.6 grams per cubic centimeter, and it asks us for the mass of 95 milliliters of mercury in grams and the weight of mercury in pounds. So let's one more time go back to the document camera. And take a look. So we're given the density of the mercury, 13.6 grams per cubic centimeter. We're given the volume of mercury, but you notice that we're given the volume of mercury in milliliters. But we know that 1 milliliter is 1 cubic centimeter. So we're able to say that that 95 milliliters is also 95 cubic centimeters. And so we're going to start with our 95 cubic centimeters. And we're going to multiply by this conversion factor that's in grams per cubic centimeter. I'm going to leave it this way because the cubic centimeters will be on the bottom and they'll cancel out. And I have 13.6 grams per 1 cubic centimeter. And so I have a mass of 95 times 13.6. And that gives me 1,292 grams, but this number only had two significant figures. So I'm going to say that that's 1,300 grams. Now, if I want to go to weight in pounds, I need to know another conversion factor. So I know that 454 grams is equal to 1 pound. And remember, you're never going to need to know these conversion factors except for 2.54 centimeters equals 1 inch. I will always give you conversion factors in problems. So we never want to round until the end. So I'm going to start with this problem of 1,292 grams times. Now this time I'm going to put the 454 grams on the bottom because I want to get rid of grams. Is 1 pound. And so I'm going to divide that 1,292 by 454. And I'm going to get that that is 2.8. Again, going back to that original two significant figure initial number. And I'm going to have 2.8 pounds. Had we rounded in the middle of this problem, 1,300 divided by 4.54 would have given me 2.85 and some change, and I would have rounded it up to 2.9. Either answer is going to be acceptable, but if you round in the middle of a problem, it does tend to introduce error. So we want to round at the very end. Okay, so that's it for density. As always, if you have any questions, make sure you write them down and let me know, and I look forward to seeing you in class.